a.m. Pacific time on Saturday, December 8th, and you're looking at a live view of the SpaceX Dragon spacecraft coasting through space as it prepares to rendezvous with the International Space Station about 30 minutes from now. My name is Tom Perderio, and I'm a firmware engineer here at SpaceX. Joining me on this early morning is NASA Public Affairs Officer Dan Hewitt. Dan, thanks so much for joining us today.
Tom, thanks so much for having me. This is my first time hosting a cargo resupply mission from SpaceX headquarters out here in Hawthorne. I'm super excited to be here. Kind of one of the coolest parts of my job supporting the space station is traveling to locations all across the globe where the action's taking place, and it's a privilege to add SpaceX headquarters to the list.
In case you missed it, Dragon launched aboard a SpaceX Falcon 9 rocket earlier this week on Wednesday, December 5th at 1:16 p.m. Eastern. Immediately after Dragon separated from the Falcon 9, it began a series of burns, which gradually raised its orbit to align more closely with the International Space Station. Dragon then received the all-clear to start its careful approach towards that station.
And this approach actually occurs in several phases, and we'll explain why that happens throughout the broadcast today. The first approach point was when it was just 350 meters away from the International Space Station. It's already passed that and moved in much closer. Once that all clear was given, it moved into 250 meters, which is where it's sitting right now at this very moment. So it's just 250 meters away from the space station. That's about 820 feet, or about the same distance as 2.5 football fields. Pretty soon it's going to get given the all clear, and it's going to depart that 250 meter hold point and enter what we call the keep out sphere, which is an imaginary sphere around the space station with a radius of about 200 meters. And this is just in place to put a big set of rules for any vehicles traveling to or from the International Space Station. There's the keep out sphere. There's also something known as the approach ellipsoid, which is much larger. But again, these are just in place for any time a vehicle's traveling to the space station. There's a bunch of gates and a bunch of checks that it has to go through before it actually gets in close for the grapple or the docking or whatever the vehicle is going to be doing. But there's a series of go, no-go polls throughout this that we're going to be listening to and giving you updates as Dragon gets closer into that final capture point.
Right now on your screen, you can see a video as it appears from the International Space Station looking at the Dragon spacecraft. Right now, we just passed into nighttime aboard the station, meaning that the station and the Dragon are currently in the Earth's shadow. So we can't see too much right now on that camera. You can see that strobe light blinking. That is the Dragon right there as it approaches the 200-meter keep-out sphere. For this perspective from the station, it does look like Dragon is kind of stationary or motionless, but it's actually traveling at an enormous velocity as it awaits clearance to proceed to the next arrival checkpoint. Right now, both Dragon and the station are traveling at 17,000 miles per hour, which is insanely fast. A commercial aircraft only travels about 550 miles per hour. And if you were able to fly as fast as Dragon, you could cover the distance from New York to LA in 8.5 minutes.
And we just heard the word that Dragon just got the go to move into that keep-out sphere, so it's going to depart that 250-meter point. It's been holding there for a couple of minutes. And again, it gets to these hold points, and the teams here at Hawthorne are just running a series of checks on Dragon, making sure the systems are behaving themselves. And then once everything looks good, they get the green light, and then they give Dragon the go. So control can actually be, or commands can actually be sent from the crew on board the International Space Station. They have a control panel where they can command Dragon to approach, abort, any number of different things. And they're also going to be in the driver's seat for the actual capture this morning. You're going to be hearing a couple of voices happen, but it's been slow and steady so far. It's actually been ahead of schedule so far. We were originally expecting to grapple around 3 a.m. Pacific time, but they've been about 30 minutes or so ahead. Not tracking any issues with the vehicle. The teams in Houston on the left there and Hawthorne on the right working in tandem for all of these operations this morning as Dragon just gets closer and closer. We're still waiting for it to arrive at that 30-meter point, which will be our next hold. That should be there within the next couple of minutes or so.
On your screen right now, you can see. You just did see those two mission control centers, one inside NASA headquarters and one at SpaceX headquarters. And there is a view of the Dragon finally coming into the sun. This is a view from the end of the Canadarm as it looks towards the Dragon. Just describing what you can see, that those are the Dragon's solar arrays on the side of the trunk, and right in the center of the pressurized capsule is the avionics bay. It's that dark spot in the middle of the Dragon capsule. That is actually the inside of the door that opened up to expose those sensors is where the grapple point is, so that camera view will get closer and closer to the Dragon on that point. But those guys at NASA headquarters are there 24/7 usually, supporting all the human activities aboard the space station.
Yeah, at the Johnson Space Center, in that room, you have people 24 hours a day, 365 days a year, and that's been the case in that room for a little over 18 years now. As long as there have been people on board the International Space Station, which the first one showed up in November of 2000, you've had people on the ground supporting them, because the people in that room are the ones who are actually flying the station right now. I mean, for pretty much every system on board, there's a console in that room controlling it. Everything from which way the solar arrays are pointed to what the temperature is inside the vehicle. They actually control the thermostat of the Ethos console, who does all the life support. And so they're in that room flying the International Space Station, supporting the crew on board, and then working with control centers all around the globe. We have control centers with all of our international partners in Canada, in Europe, in Russia, and in Japan, all supporting their different modules and equipment on board the International Space Station, and then also obviously working in tandem with control centers from our spacecraft providers like SpaceX, like we're doing this morning.
The guys and girls at the SpaceX Command Center are not there 24/7, but whenever a Dragon spacecraft is in orbit, it is constantly manned, and we always keep track of exactly what the Dragon is doing. .30-meter hold in just about a minute from now.
We'll start seeing some clouds now, as now moving over the Terminator line, one of my favorite space terms. That's that line between night and day on the Earth's surface, and you're going to see the clouds start to come into view. The station and Dragon right now flying over the southern Pacific, about to make a swing just over the very southern tip of South America, passing over the mountains of
That Dragon just continues to get closer to the ISS cameras, filling up more and more of the view. Dan and I have been now watching the Dragon for the ISS and the Dragon for a few orbits. We've seen it cover almost all the major continents on the globe. Right now, they're currently flying over northern China.
Yeah, Dragon getting really close now to this 10-meter point. This will be the second time around, but last time they had to back off while they worked a ground issue with, you heard it called TDRS a lot. That's the Tracking and Data Relay Satellites. That's how we actually have communication with the International Space Station, and they had an issue with those systems on the ground that eventually got resolved. And as you can see, we're back in communication with the space station, obviously, as we're getting this live video down. Everything, again, continuing to progress smoothly. This is another peek inside the interior of the space station, looking over the crew's shoulder at the monitor that they're using to watch Dragon during this final approach. And as soon as it hits that 10-meter point, it'll be over to the crew to get the go to capture, reaching out with that robotic arm, and fixing to the grapple fixture, and then we are just about at that capture point.
This is the second approach of the Dragon tonight, but it is not the first time this Dragon has visited the International Space Station. As we said before, this is a reused Dragon spacecraft. First flew in the CRS-10 mission back in February of 2017.
So yeah, Dragon getting closer and closer. This is a camera view we're going to see a lot of, and especially as that arm starts moving in, because this is a camera sitting right on the end of the space station's robotic arm. That robotic arm called the Canadarm2, and this is sitting right on top of what's known as the LEE, and that's an acronym that stands for the Latching End Effector. That's essentially the hand of the space station's robotic arm. It's used not only to hold the robotic arm, there's one on either side of it. So one end right now holding itself to the International Space Station, the other going to be used to grapple with that Dragon spacecraft. This arm, very versatile, used for a whole bunch of different operations, not only just capturing spacecraft, but also flying spacewalking astronauts around, and was used to build the International Space Station piece by piece. So it's under the control of astronauts on board right now, who got it into its current position just a little while ago when we started all of these final rendezvous procedures. And it's going to be Alex Gerst inside, the current station commander, who's going to be controlling this arm, driving it in and capturing Dragon out of the sky.
That end effector is going to be mating with the grapple point on the Dragon, and you can see that that is on the inside of that GNC, or Guidance, Navigation, and Control door. For launch and re-entry, that door is normally closed, flipped around and sealed up. On the outside is the same thermal protection system material that we have on the outside of the Dragon that helps protect it from the atmosphere and from that re-entry heating. And the reason that the grapple point is on the inside is because it's not a perfect aerodynamic surface, and because it's a sensitive thing that the ISS needs to grab onto, we want to protect it during ascent and then re-entry. So it's tucked away on the inside.
Station Houston on Space to Ground 2 for Dragon.
Go for Dragon.
Okay, confirm capture point hold for step 6 in 1.102.
Copy, step 6 will work.
All right, so Dragon is at that capture point once more. This kind of feels familiar, Tom, but it is sitting 10 meters away from the International Space Station right now. So what the teams are going to do is quickly do their go, no-go polls again, making sure that everything's good on the station side and on the Dragon systems to give the crew the go to actually reach out now with that station robotic arm and capture the Dragon.
Houston Station on 2, capture conditions confirmed and crew ready for Dragon capture.
And Station Houston on Space to Ground 2, you are go for the capture sequence. Perform step 4 in 1.110, Dragon capture. Begin monitoring the back away cue card.
All right.
Houston, copy, go for capture. Just clarifying, we thought 12:18 would be the time of the opening window.
Yeah, we were more efficient than planned, Serena.
Copy that, Houston, go for capture.
All right, well, those are exactly the words we wanted to use. Everything is now go for capture. So the crew's going to start working through some final steps, and any moment now we're going to start seeing that robotic arm in motion. So now we're just moments away. So it took a little while to get here. We overcame a couple of issues with our ground communications, but now we're here. Dragon's just 10 meters away, and it's time to capture.
We heard more efficient than expected. That sounds great to me.
Always good to hear.
Dragon is now filling up most of the view of those cameras, especially the one on the end of the Canadarm. We're going to see it get very close to that grapple point on the GNC bay door. As we mentioned earlier, at this point, Dragon's actually not doing any more moving. It is holding at the 10 meters point, and from now on, it is the station crew moving the Canadarm towards the Dragon.
That's right. They're gonna close in. It's a very, just like everything else so far, it's a very slow and methodical process to drive that Canadarm in. And once it makes that initial contact, they'll get kind of a light hold on it, and then a series of snares will draw that grapple fixture all the way into the robotic arm, giving them a tight hold on the spacecraft, at which point the crew is done with their activity for now, and they hand over to the ground to actually maneuver Dragon using that robotic arm and attach it to the Earth-facing side of the space station on the Harmony module, also known as Node 2.
Now, my experience has mostly been with the Dragon spacecraft approaching the International Space Station, but Dan, I imagine you've seen a lot of vehicles visit the ISS and have a lot of experience seeing not only Dragons, but Soyuz, Progress, all the visiting vehicle family of the International Space Station come to dock and berth.
Yeah, and it's always interesting because they all kind of have their own little differences between how they do that. Obviously, with today being a berthing, so you have a grapple portion of it, whereas with like a Soyuz or a Progress, it's all a docking and they just kind of drive straight in. I typically tend to prefer those personally just because they're usually a little bit quicker. But I mean, they're always interesting operations. Like, it's still space flight, it's still crazy stuff happening 250 miles above us. But it's always fun to see a vehicle arrive at the space station. It always means a flurry of activity, both before, during, and after. So especially with Dragon here now for the crew, they're going to be really busy. And there's going to be a bunch of new science experiments that they're going to bring off and work on. And those are always interesting to track along, working on all these different disciplines, from monitoring the Earth below us to doing new research on drug breakthroughs and things of that nature as part of the U.S. National Lab. So, yes, it's always interesting to see a vehicle get there just because of all of the other, kind of the cascade of events that it always brings with it.
It is pretty cool that we have this international laboratory that has so many different...
Traffic always picks up for the space station.
All the kids are coming home.
Oh, yeah, everyone's coming home. And this isn't even the end of the year. This isn't even the last kind of big thing for the year. So Dragon's going to attach, and then 3 of these crew members are coming home in just about 12 days. 3 of them, including Alex Gerst and Serena Anand-Chancellor, who are doing this activity. They're actually scheduled to land along with Sergei Prokopiev coming up on December 20th. So for them, it's going to be a heck of an end to their mission. They've been on board the space station since June earlier this year, so
That's
wrapping
crazy.
up about 6 months for them. They were originally scheduled to come home a little bit earlier, but everything got kind of rescheduled with the Soyuz flight schedule. But yeah, this will be kind of the last thing capping off their time on board the space station. This was Serena's first flight, and this was actually the second for Alex Gerst. But we're almost at that capture. That station robotic arm going to slowly start maneuvering in. Again, it's Alex Gerst at the controls. He's using, it's kind of like video game controls. It's a joystick and a hand controller inside the space station. So he's going to be driving in, Serena Anand-Chancellor backing him up, making sure everything looks good with all their measurements and their camera views on Dragon, and also doing the voice comms with the ground. But you can see it ever so slightly getting closer now.
That view from the cupola must be unbelievable. I don't know how I'd be able to get anything done with a view like that on my window.
Every single one of them says, you ask them what do they do with their free time, and they go just spend time looking out the window. If you've ever seen any video from the space station or any of the really crazy time lapses they've done of planet Earth, pretty much all of those get taken from that cupola module. And it's this big 360-degree bay window that we use for a lot of Earth observations, but it also provides a wonderful vantage point for operations like this. It's right near the docking port or the berthing port where Dragon's ultimately destined for, and it provides a stellar view of all of the operations of these arriving spacecraft.
It's got to be one of the biggest windows ever flown in space on that cupola or something similar to that.
It's definitely up there. It's larger than any other window on the International Space Station. It's actually a series of a bunch of different window panes, all in one kind of small module. Any Star Wars fans out there, it looks kind of like the window on a TIE fighter, if you will, and it provides this 360-degree panoramic view of the Earth below and also spacecraft. But for now, we're getting closer. We're just a couple of meters away now. You can see that grapple fixture right in the center of the crosshairs now, and this is a view from the end of that station robotic arm.
We are actually close enough now that you can see the movement of the Canadarm. Too slow or too far away to see the slow movements before, but we are definitely approaching that grapple point.
And hearing we're less than a meter away.
You can see on the left how far that arm has come. It's right up against the side of the Dragon now.
All right, we're going to stand by for that initial capture. Here we have a good alignment. And the capture's been commanded. All right, and that is a capture. Capture coming at 4:21 a.m. Pacific time, 6:21 a.m. over in Houston. That's where my computer's time is set to, but that capture is confirmed. Again, 4:21 a.m. Pacific time, with the space station flying 250 statute miles to the north of Papua New Guinea, just out over the Pacific Ocean. We got it. We got it.
Finally, we did it.
But so again, Dragon's captured. We'll stand by for a little bit. Usually the crew likes to offer some words, but they were able to do that successfully. Once they recovered from that ground communication issue, the teams got through all their procedures real quick, and now Dragon within the grasp of the Canadarm2, and just one step closer to being attached to the International Space Station.